Hello everyone, I'm Xavier JACQUES from Simpa company, and for this talk I will talk to you about a software we have developed for Airbus using the GEF4 framework, a software that was allowing a user to create a cabin configuration and geometry of aircraft fuselage. So first, I will talk about the main user interaction we provide through the tool. Then the main GEF4 component involved on the software. Then I will present how we have made the 2D, 3D geometry calculation thanks to GEF4 geometry plugin. And we will finish by a small video of a cabin simulator we have done on top of the fuselage configurator. So in fact, Airbus wanted a software to create a new fuselage aircraft configuration that was easy to use for its engineers and allow unconventional aircraft configuration like flying wing, for example. And the geometry calculation needed to be as precise as possible, like the millimeter precision. So in the past, we developed some RCP application for Airbus. So we first look at the framework that was providing graphical editing. And then we found that GEF4 version, newborn version of GF was released and was fulfilled every requirement we had. So what is GEF4? So it's an editing framework for a graphical application. So you can draw some shape. Also, you have components to display graph. So we have started the project 2 years ago. So GEF4 was in its first beta release. So it was a bit risky for us to begin with this framework, as you don't have some tutorial on internet or many feedback from early adopters. And now we are currently running our application with the new release of GEF4. So here you can see the main views of the application we have created. So you have a top view with the aircraft geometry with the wing and other components like outside components like trucks, passenger bridge. You have a side view and you can see door and the different decks. And the front view, where you can see the elements at a given position on the aircraft. You have also two other views, passenger deck views, that is displaying all the main components of a passenger deck, like the seats, passenger aisles, lavatories, and a cargo deck view, that is displaying a cargo container and cargo compartments. So now we will see all the user interaction we provide thanks to GEF4. So to navigate through the drawings, we have implemented a zoom in, out, and pan. You will see on the video the rendering we obtain. So it allows easy move for the user. And as you can see, the element thickness are adapted to the current zoom level where you are. It was very important for the user. It was the thickness adapted. So you have also hovering above the drawing elements. So you have a selection over where you draw the contour of the elements in blue at the top. And we also provide an over menu when the user has the mouse above an element. A menu is displayed at the right to allow user to do some action, like for example deleting the element, rotate it, or duplicate it. So for the hovering also, one main important thing you have to know about, it's for the line, the curve. when you have scene lines, it's very difficult for the user to select them. So GEF4 provides to increase the clickable area for this element. So as you can see on the drawing, the hover is triggered even if the user is not above the scene line. So we provide also a palette that is bound to a side of the drawing view, and it is triggered when the user is focusing it. So with this palette, the user can create elements in the drawing or trigger some action in the drawing view. We provide also another palette for creating elements also. When the user right-click on the drawing, and it will create an element, selected elements at the position the user has clicked. And on the rendering scene, you can add some JavaFX components like this palette that is a pop-up as an overlay or underlay of the viewer. Another JavaFX component we have integrated into the viewer is a JavaFX table view, as the user, in fact, wanted to have a global overview of the number of elements, of aircraft elements he has in its deck. So the table is displayed in overlay of the viewer, and the user has the number of seats present in the deck or other things useful for him. So I will display a video for element creation that you will see. It is very fast to create some row seats. So you begin, the user begins to create a seat, then tell he has 3 seat rows. Then with the over menu, he duplicates the first seat rows, and then he can select the seat blocks, duplicate it, and after the user can drag and drop the seat blocks to adjust its position in the deck. So we also provide a front view, as the user, in fact, wanted to check the height positioning of the elements into the aircraft. So this front view is recalculated as the user moves the black arrow you can see on the side view at the left. So, So the user drag and drop the black arrow, and you have the front view recomputed with elements located at the position where is the black arrow in the aircraft. So it allows user to check if some elements are outside the fuselage or not. Also, the user wanted to have the possibility to measure the spacing between every element in the drawings. So we have provided a measurement feature. So the user can put a start position, and then measure band to band the spacing between the two positions. Once he has created its measurement, he can drag and drop the extremity of the line to adjust it. And he can, the line also snap to the corner of the different elements of the aircraft. I will talk then about the main GEF4 components you will need to use to have the results I have shown in previously. So GEF4 is based on a MVC architecture. So you have the visual part object that is acting as the controller for the drawing elements. So the visual parts are created by a part factory that will create the visual part and associate its content, that is a model. And then the visual part is responsible to create and refresh the visual that will be displaying in the viewer. So the viewer is a view that has star visual part inside. For user interaction, you need to use the policy and a behavior object that are bound to a visual part. So you can say a particular drag and drop policy is bound to a visual part managing, for example, the lavatory. And all this stuff is configured by an MVC module where you say which policy is bound to which visual part. So to enter in detail for the visual part, so it manages the visual rendered in the viewer, and you have 3 different visual parts. One for the content part, that is your model, so the main elements you will draw in the viewer, like the seat you see. You have a feedback part that is responsible to draw the contour of the elements when they are selected, and it is drawn on top of a content part. And then a handle part that we have not used in our software, but is responsible to draw the small circle you see at the bottom to allow user interaction on the line drawn. And the handle part are rendered on top of feedback parts. So for the MVC module, so GEF4 provides an MVC FX module that provides the default binding for JavaFX. So you have already, when you start, the feedback, the user interaction, the scrolling already enabled. And if you want to change some default behavior, you need to override this module. Like if you want to remove the small circle at the bottom, you will need to override the hover bindings. Now the viewer, you have also a default viewer provided for JavaFX. So it's populated by visual part, and it uses in fact the scene component of JavaFX, where will be rendered all the drawings. So internally in the viewer, the model is represented by 4 different models, content models for all the content you are displaying on the viewer. The selection model, storing the element selected, the focus model to know where element is focused, and the hover model to know what is the element hovered, the current element hovered. And you can manipulate these different models with the code. So for example, if a user selects in other side of the software an element, you can select it by changing the model of the viewer, and the selection will be drawn into the viewer. So for the policy, so it's bound to a visual part. So you have 2 main parts, 2 main different policy types. One for interaction, so that will be a drag and drop, scrolling, click, selection. And you have also a transaction policy that will be used for by other policy, like interaction policy. When, for example, after an interaction, you want to save the state of the final state after the interaction. So you can see some usage examples of the policy. So for the behavior, it's not like the policy. Well, it's also bound to a visual part, but it is not reacting to user interaction, but it's listening, in fact, to the model change of the viewer. So for example, when a user will select an element, the selection behavior associated will be triggered. and will, for example, provide the feedback and create the feedback into the visual. So also some usage example on our application, like for palette focus and the clickable area default size change. So we'll talk now about how we have done the geometry 3D calculation. So you have a geometry plugin into GEF4 that provide 3 main geometry interfaces. So eCurve is for line, multi-line, and curve, like a Bezier curve. eShape it's for closed shape, like a triangle, rectangle, polygon. And eMultiShape is when you have multiple shape into a single element. And it provides a lot of utilities, like to know when a geometry touch another one or is intersected it, and and to know the point of intersection. And we have used these methods to make our 3D definition of the fuselage. So how we modelize the fuselage in 3D. So you have the aircraft, and we will discretize the aircraft into a multiple cross-section that you can see in red, and a cross-section is a cut of the fuselage geometry at a given position. So the user, to define the global geometry, has the possibility to create its own cross-section that will drive the entire geometry. So in the example I will show, the user will create 3 elliptical cross-sections, and then the software computes automatically the other cross-section, and we will see how it computes this cross-section after. First, when you have the user-defined cross-section in red, we need to calculate the aircraft envelope definition. How we do that? We create 360 segments at every degree of the circle, and we relay each other cross-section with the segments. And so to relay a cross-section to another, it is interpolated with splines. So you can see what it looks like. And now, as we have the aircraft envelope definition, we can now compute the cross-section. So to compute the cross-section, in fact, it is at a certain position. It will be the intersection of the 360 segments and the plane. So it will give us 360 points that we will store as a polygon. So you can see an aircraft geometry example where the user has defined 3 main cross-sections. The 2 outside are big, and in the center are smaller. And you can see how the geometry of the aircraft is a change due to the cross-section on the top view and side view. So now, as we have our fuselage, our geometry fuselage defined, we can calculate, for example, a floor, a deck floor. So in fact, the user just defines the height of the floor in the aircraft, and after the software calculates the geometry of the floor. Or how we do that? So we create a plan at the given height, and we will do some intersection between the plan and every cross-section we have calculated. So it will give each time 2 points, and then with all the points you gather, it creates the floor shape you see. And this floor shape is also saved into a polygon, and you can see what it looks like when it is displayed in the top view. we also implemented a collision check engine. It was for the user to verify the aircraft they have created is correct or not. Like for example, you have the seat that is over an AC space at the left of the drawing. And also it was very important to know if an element is outside of the fuselage. Like you can see for the rear seats, on the 2D view, you don't see that the seat is out the fuselage. And with this check, you can see on the front view that it is a little outside the fuselage. And so for this, we use a lot the utility methods provided by the geometry plugin of GEF4. So I will show now how a cabin simulator we have built in top of the passenger deck view the user creates. So in fact, it's a multi-agent simulation to simulate boarding and deplaning of a passenger into the deck created by users. And the user can change define the different size of a passenger, where they will sit, or different strategy of boarding and deplaning. So it's fully based on the viewer we created to create the cabin layout. So thanks to GEF4, we reuse all the code we have wrote for the fuselage configurator, and we have just removed a user interaction that was configured into the MVC module we have seen. And we just add the drawing of passenger and luggage. So I will launch a small video demo of a complete boarding. So it's a boarding on 2 decks. So you can see the passenger going through the aisle. So you can speed up the simulation. So you can see the passenger with their luggage, stowing the luggage into the overhead compartment. And for this simulation player, the performance of GEF4 are very good. We have done simulation over an aircraft over 800 passengers and refreshed 8 times by a second, and the performance was very good. So to conclude this talk, it was very hard to start with the development with GEF4, as it was the first beta release at the start, and we had some hard time to apprehend all concepts provided by GEF4, as you have a lot of concepts to learn, and you didn't have some tutorial on internet or on Stack Overflow. You had nothing also. And so we had to dig into the source code to know how it works. And the main difficult things to learn, it's how the binding and injection are working, and in which time they are done when you create the viewer. So how we have learned at the start, GEF4 provides a full logo example where you have a lot of interaction and example provided for policy, for behavior, for configuration of the module. And we are very satisfied from the results we have got with it. Users are very happy to use the software. They find it very easy to use. They are also satisfied by the rendering we got. And I would like to finish by thanks Alexander Nyssen and Matthias Weinand for the work they have done on the framework and the help they give us on the GEF4 forum at the start of our project. Thank you. If you have a question. In fact, we already developed some Eclipse RCP application for Airbus. So we had already a background, and the user also was used to use this type of application. So we first start to look at what offered Eclipse RCP, and then we found GEF4. And as it fulfilled all our requirements, we started with it. We have done a small proof of concept, and we decided to continue with it, in fact. But I know that we could have done with Unity or with other software. But I finished. One thing with Unity, maybe you have a server behind, and I know with Unity, the client-server communication is not very easy sometimes to do. Yes?
You said that GEF4 fulfilled your needs, but you also used JavaFX. This is because you have some stuff from before, you have some missing widgets.
No, in fact, I did not explain that well, I think. GEF4 use the JavaFX send component to render all you do with GEF4, in fact. So it's you have to use the JavaFX send with GEF4. It's mandatory.
You talk about the palette on the left and the palette on the right. The one on the right pointed out that it's JavaFX, while the other one is...
It's a GEF4, in fact. It's a component created with a GEF4. And the right-click palette, in fact, was a JavaFX pop-up that is displayed on top of the view, like the JavaFX table also. So you can integrate easily JavaFX component into your viewer.
And then listeners and events are JavaFX or GEF4?
Both. Yeah, and it's a very start also to, if you never learn JavaFX and GEF4, as it was our case at the start, it's very hard to aggregate everything into the right thing. Yes?
That was a very nice cabin simulator where you showed the boarding of the people. Did you have any chance to compare the simulating times to real boarding times?
Yes.
And was it similar or?
Oh, it's in current development. So we finish the drawings now and the simulation, and now we will go to the compare phase to do some tweak about because we define some variables that we don't know if they are right or no, and we will compare to real aircraft measurements of boarding, and we will adjust our simulation parameters. Oh. Okay. So thank you.